This is for Year 11 methods. It comes out of 3.5. It's question number 4 and question number 5. For question number 4, a y equals x to the power of 4 minus 3. So this is in turning point form. This one here used to be like this, but it's been moved down 3. So I know my graph will be going to look like this, a very U-shaped parabola with a turning point at -3. I know it's going to have x and y intercepts, so I need x intercepts. I've labelled my y intercept. To get the x intercept, I set y equal to 4. Move the 3 over. Take the fourth root, so x equals the fourth root of 3. It's going to equal plus or minus the fourth root of 3. This is going to be the positive fourth root of 3. This will be the negative fourth root of 3. And that's what the graph looks like. If I was to look at 4c, I've got y equals x plus 3 squared, x minus 4 squared. This x power 2, this x power 2, multiply them together, I add the powers, so this is a degree 4, and it's a positive degree 4. That x squared is squared, so it will be positive, and that will be positive. So, with a positive squared, I know that it starts up here and finishes up here. All the even numbered powers do. It touches at x equals -3. It touches because of the power 2. It also touches at x equals 4. So I've got touch, go up, come down, touch, go up. I need to find the y-intercept. That will be when x equals 0. And that will be when x equals 0. 3 squared is 9. 4 squared is 16. 9 times 16, 9, 6 is a 54, carry 5. 144 will be my y-intercept. Okay, in question 5, use CAS to help you draw the graphs of each of these points. Okay, so here's a quartic. I've entered on the calculator x to the power of 4 plus 3x squared minus 2x plus 3. I'm going to drag and drop it into my graph. And I need to explore a little bit. So I might go zoom auto, and zoom auto will automatically change the y values to match that domain. And it looks as if it's just a U-shaped quartic that doesn't have any bumps associated with it. I might just zoom in here just to put a rectangular box around it to see whether there are any points where it starts looking like this. I'm wanting to make sure that it doesn't look like that. Now, if I go to analysis and go minimum, if there's more than one of these minimums, then it will find them both. And if there's looks like that, then there'll be a maximum. So I might go analysis, G-solve minimum. And if I go to the left, there's no other, and to the right, there's no other. If I go analysis, G-solve maximum, there's none found. Okay, so I've got one minimum, and that's where my minimum is, and x equals 0.3. So I'm comfortable to now draw it, that I know that it has a y-intercept of 3. I know that because if I make x 0, I get 3. And it has a turning point at 2.6 and 0.31. So that's 0.3, that's probably 1 there. So my graph looks like that quartic, where I have a turning point there. If I was going to do 2 decimal places, 0.31 3, 1, 2, so 3, 1, and 2.67 has a y-intercept of 3, and that's what it's going to look like.